Okay, in this video we're going to discuss the measuring of basic angles using the unit circle. But before we get into it, the one thing that you need to understand that all the angles, they are measured from that point here, and I'm talking about the point 1, 0. So that would be the 0 degrees or 0 radian angle. And then measuring an angle, you're going to have to go anti-clockwise for positive angles and then clockwise for negative angles. So as you can see here, the angle theta, assuming that this is this one that measures angle theta, then the minus theta will be the reflection backwards, right? You can see it on the shape next door, but basically this is going to be the negative theta. Now, application of all of that would be the following. Once we know specific angle, then we can find all the possible reflections around, but also we might be asked to calculate, let's say, for example, the angle which is pi plus theta. So number one is already drawn there, but let's go with a number two. So I want to calculate the angle which is like pi plus theta, and what would have been in relation to the angle theta that I have here, with this being my angle theta. So I know that pi is all the way to 180 degrees. So pi plus theta, it's enough if I extend that line. These angles theta and that one between pi and the new line that I drew, it's also going to be theta. These are vertically opposite angles, so they have to be the same. So the pi plus theta can find itself in that position roughly. So if I want to know what is the sine of pi plus theta in relation to the sine of theta, then I have to do the following thinking. If I go to the point, let's say P1 here, whilst this one is going to be the point P2, then the sine of the P1 theta, right, corresponds to that length, which is the projection along the y-axis. So let's write this one, that this is the sine theta. The sine of pi plus theta, it's the symmetrical but below the x-axis, and this is going to be the sine of pi plus theta. So what we know is that the sine of pi plus theta is minus the sine theta, because the one of them is above the x-axis while the other one is the reflection below the x-axis. Similarly, you can calculate all of them. So let's just pick up one more. Let's just say number 6. And let's just clear up all the drawing here. You can always pause the video and go back and look at it again. The angle that I'm working with is the 2 pi minus theta. So I'm going to have to consider that I'm doing a full circle to go to 2 pi. But then from the full circle that I'm going to 2 pi, I'm taking away the angle theta. So if I go backwards, let me just delete the 2 pi. That would be the angle which is the 2 pi minus theta. Yeah. And then that also corresponds to the angle theta below the x-axis. So what I have here, I have the cosine of 2 pi minus theta. If we consider the projections, so we know that the x projection is going to be the cosine of theta, and then if I do the same projection here, you will see that the cosine of 2 pi minus theta corresponds to the same length as the cosine theta. So that would give me that the cosine of 2 pi minus theta is equal to the cosine of theta. Similarly, you can calculate, like I said before, the rest of the angles, but you can pause the video and you can try, and then you can kind of see the answers. The sine of pi minus theta, pause here if you don't want to see the answers, it's going to be equal to the sine theta. The sine of 2 pi minus theta will become minus sine theta. The cosine of pi minus theta would become minus the cosine of theta. The cosine of pi plus theta would become minus the cosine of theta. The tangent of pi minus theta will become the minus the tangent theta. The tangent of pi plus theta will become the same as the tangent of theta, and the tangent of 2 pi minus theta will become minus the tangent of theta. The tangents, you might find them a little bit confusing, but essentially the tangent of, let's do the tangent of pi minus theta, that becomes the sine of pi minus theta over the cosine of pi minus theta. Now the sine of pi, which is here, minus theta, it's going to be the projection, it's going to be the same as the sine theta, over the cosine of pi minus theta, which is going to become that projection here, which is the negative of the cosine theta. So you can see now that this is negative tangent of theta, and this is how you can calculate using the unit circle all around it. Part 3 for this video, and based on that understanding we discussed here, you can complete the unit circle for the basic angles, and I'm talking about the angles 0, 30, 45, 60, 90, and all the multiples. If we start one of the 90 degrees, which is going to go here, 90 degrees, that's going to be an easy one because the coordinates in the unit circle, they're going to become 0, 1. That means that the cosine of pi over 2 or 90 degrees is going to be equal to 0, and the sine of pi over 2 or 90 degrees will become equal to 1. The rest of the angles, and of course this is the pi over 2, for the rest of the angles you can use symmetry. Let's say, for example, if I want to calculate the ratios for that specific angle here, which is going to be the 150 degrees through symmetry, then I can look at the corresponding 30 degrees of pi over 6, right? The x value, the y value remains the same for both angles, whilst the x value becomes the opposite. So what I'm going to have for that, for 150 degrees, I'm going to have the negative root 3 over 2 for the value of the cosine, and for the sine will remain a half. Let's do one from the third quadrant too. Let's just pick up, for example, that point down here. That will be the point that is going to be 270 minus 30, or another way to calculate it is, because this angle here is equal to 60, then the corresponding, due to vertically opposite angles, is also going to be 60. So 60 plus 180, that's going to give you the 240 degrees. And then if you look at the corresponding ratios, here you have 1 root 3 over 2. They are both positive, whilst in that position here they're symmetrical and negative. So the corresponding ratios are going to be negative a half, comma, negative root 3 over 2. And what that means is that the cosine of 240 degrees is equal to negative 1/2, and the sine of 240 degrees is equal to negative root 3 over 2. That's the way you can calculate all of them. You can find answers through the tools that I've shared with you in OneNote, but also you can Google the trigonometric, the basic ratios for trigonometric angles in a unit circle, and then you can check your understanding and whether you can get them all correct.